Oh hey, I didn't see you there. It's just about to get started with our pre-algebra lesson. Today we're going to be doing 6.4, solving systems with elimination. Print out the PowerPoint and work the problems with me. Now let's get started.
It's Virtual Math with Mr. Ferrara.
Hey, what's up everybody? Today we're going to be continuing section 6.4, solving systems of equations with elimination. Today's elimination problems are going to be a little bit more complex than last lesson's problems. In last lesson's problems, there was one variable that was clearly ready to be eliminated. In these problems, x's and y's are all going to have coefficients. It's not going to be as obvious. Now, just a reminder, the steps to solving or elimination are as follows. Step 1, you want to get x and y both on the same side of the equal sign. I am not going to be tricking you. They're always going to be set up for elimination. X's and y's will always be set up on the same side of the equal sign. When you get to high school next year and you do these topics again, your teacher is not going to be as kind. Step 2, you need to determine which variable you want to eliminate. If there's an x and a y by itself, that's probably the one you want to concentrate on. Today's lesson, they're not going to be as obvious. We're going to have to figure out which variable we want to eliminate. Once you figure it out, you need to multiply the equation, add the two equations together, and solve for the other variable. Step 4, you're going to plug the variable back in to find the other. If you solved for x, you'll need to solve for y. If you first solve for y, then you need to solve for x. Just a reminder, if one variable does not cancel, then you're doing this problem wrong. If at any point you don't have one variable canceling with another, you should reevaluate how you're doing this problem. This would be a good time to tell you that mystery word number 1 for this week is LPA. The school that you used to go to is LPA. All right, let's jump right into some examples. Now, these are going to be a little bit trickier than last lesson's examples. These are going to involve either not multiplying at all or maybe multiplying both equations. So if we look at the first one, 3x plus 4y equals 10 and 2x minus 4y equals 0. I look and see, are there any variables that are by themselves? There's not in this problem, and there's not going to be in all of the problems that we do today. But there is a little shortcut to this problem. I notice that I have a positive 4y and a negative 4y. I know that a positive 4y and a negative 4y are going to immediately cancel. So in this problem, you don't have to multiply by anything. You can just add these two equations together because I have the opposite already. Positive 4y and negative 4y added up cancel each other out. 3x plus 2x is 5x, and 10 plus 0 equals 10. Could you have done this problem where you got rid of the x's? Sure. Is it easier doing it this way? You better believe it. Divide both sides by 5. You get x equal to be 2. 10 divided by 5 is 2. Well, when I find the x, I also need to solve for y, so I pick an equation. I'm going to pick the top one, which is 3x plus 4y equals 10. I know that x is 2, so I'm going to plug in 2 in for x. Multiply, I get 6 plus 4y equals 10. I'm now at a two-step equation. Subtract 6. I get 4y equals 10 minus 6 is 4. I'm left with a one-step equation, so I divide by 4, and I get y to be 1. So again, why was this problem a shortcut? Because I had a positive 4y and a negative 4y. Anytime you have opposites, they immediately cancel out when you add your two equations together. Final answer is x comma y, 2 comma 1. Answer to the first one. So be on the lookout for opposites when we do these problems. That'll save you some time. Now example 2, negative 3x plus 2y equals 14 and 2x minus 5y equals negative 13, unfortunately doesn't have a variable by itself, and it doesn't have one that immediately is going to cancel with another. So I'm going to have to change both equations. Well, I look at the x's. I could work with either x's or y's, but I'm going to choose to work with x's on this problem. I have a 3 and I have a 2. There's nothing I can multiply a 2 by to give me a 3. Not whole numbers, that is. So I need to multiply both of these equations. Where is the first time that a 3 and a 2 will meet up? What is the least common multiple of a 3 and a 2? Well, the answer is 6. I can change a 3 into a 6 and a 2 into a 6, and therefore they would cancel. So I'm going to make this top one the negative 6, since it's already got a negative. So I get negative 6x plus 4y equals 28. Now, if I have a negative 6, I need to cancel that with a positive 6. So can I turn this 2 into a positive 6? I can by multiplying it by 3. 3 times 2x is 6x. 3 times negative 5 is negative 15y. And 3 times negative 13 is negative 39. I'm going to add these two equations up. Now, if a variable does not cancel, you need to do it over because it didn't go right. But I do notice that negative 6x and positive 6x cancel. 4y plus negative 15y is negative 11y. And 28 plus negative 39 is also negative 11. I'm at a one-step equation. You should always be at a one-step equation, so I divide by negative 11. And y equals 1. Well, if y equals 1, I need to solve for x. So I pick an equation. So let's go with 2x minus 5y equals negative 13. And I plug in y for 1. 2x minus 5 times 1 equals negative 13. Multiply 2x minus 5 equals negative 13. You'll get to a two-step equation. I add 5 to both sides, and I get 2x equals negative 13 plus 5 is negative 8. Divide both sides by 2. Negative 8 divided by 2 is negative 4. So my equation, my solution, is x comma y, which is negative 4 comma 1. Again, trickier problem because now we're going to do problems where we have to multiply both equations in order for one to cancel. A little bit harder to see, a little bit harder to work with. Could we have gotten rid of the y's? Sure. What's the least common multiple between 2 and 5? Well, the answer to that is 10. I could have multiplied this equation by 5, this equation by 2. That would have given me a 10 and a positive 10, and they would have canceled. So there are multiple ways to do these problems. If I do a problem differently than you did, it doesn't mean that you're getting it wrong. You may have just opted to get rid of the other variable. All right, 9x minus 3y equals 15. 2x minus 5y equals negative 1. Unfortunately, again, I don't see a variable by itself. I don't see one that can immediately turn into another. So I'm just going to work with the x's, 2's and 9's. What's the least common multiple between 2 and 9? Well, the answer to that is 18. I could turn a 2 into an 18, and I could turn a 9 into an 18. Well, I'm going to turn the 9 into the positive 18. 2 times 9, 18x. 2 times 3y is a minus 6y. 2 times 15, 30. Now, if I have a positive 18, I need a negative 18. And in order to get a negative 18, I'm going to multiply by negative 9. Negative 9 times 2x is negative 18x. Negative 9 times negative 5 is a positive 45y. Negative 9 times negative 1 is a positive 9. So I have my two equations. Is there one that's going to cancel with another when I add them up? The answer to that is yes. 18x and negative 18x cancel each other out. Negative 6 plus 45 is 39y, and 30 plus 9 is 39. You should always arrive at a one-step equation. Divide both sides by 39. We get y equals 1. Well, if y equals 1, we need to solve for x. Pick your equation, so I'm going to just stick with the first one. 9x minus 3y equals 15. I found out that y equals 1, so I plug it in. 9x minus 3 times 1 equals 15. Multiply 3 times 1, I get 3. And I'm at a two-step equation. Add 3 to both sides. 9x equals 18. Divide both sides by 9. I find out that x equals 2. So my coordinates are x comma y, 2 comma 1. So there's the third example done. Let's take it one more together, and then you'll try 2 on your own. 6x minus 9y equals 12, and 4x minus 6y equals 8. Again, there is no clear variable that's going to eliminate. There's no variable by itself. There's nothing that turns into another. So I'm going to work with the x's. 6 and 4, what's the least common multiple of 6 and 4? Now you could say 24, not wrong if you do 24s for both of them, but the lowest common multiple will be 12. So I'm going to multiply this top equation by 2 to get 12. 12x minus 18y, and 2 times 12 is 24. Well, now I multiply this bottom equation by something to give me the opposite of 12, which I want negative 12. Well, what do you multiply 4 by to get to negative 12? You multiply by negative 3. Negative 3 times 4x is negative 12x. Negative 3 times negative 6y is positive 18y. And negative 3 times 8 is negative 24. I'm going to add these two equations up, and you should notice something interesting happens. 12 plus negative 12x, they do cancel, which I wanted. But negative 18 and a positive 18 also cancel. So I'm left with nothing on the left side. No x's, no y's, I'm left with 0. I'm left with nothing. 24 plus negative 24 also equals 0. Well, how often does 0 equal 0? 0 always equals 0, which means my answer is infinite solutions. This is an infinite answer. When you have all your variables cancel and there's a 0 on the other side, that's an infinite solutions answer. All right, why don't you try the next two problems, see how you do with these. We'll compare answers. Now, just a reminder, you may do these problems differently than I do, but we still should arrive at the same answer. Pause the video, see how you do. All right, example 5 is 4x negative minus 3y equals negative 18. 4x plus 9y equals 30. Now you could work with the y's, but I noticed that the x's are immediately opposites of each other. There's no multiplying to make them opposites. So I can add these two equations together, and these two will immediately cancel. Negative 3y plus 9y is 6y, and negative 18 plus 30 is positive 12. I'm left with a one-step equation. Divide by 6. We get y equals 2. This is a good time to tell you that the second mystery word is divide, like I just did, 12 divided by 6. I divided. Divide is the mystery word, D-I-V-I-D-E, divide. Now, since I got y equals 2, I need to solve for x. I'm going to use the bottom one, since there's only positive numbers in the bottom equation. 4x plus 9y equals 30, y equals 2. 4x plus 9 times 2 equals 30. That's 4x plus 18 equals 30. Subtract 18. 30 minus 18 is 12. So I get 4x equals 30 minus 18 is 12. Divide by 4. I get x to be 3. So the point where they meet is x comma y, or 3 comma 2. Okay, and the last one. So problem 6 is our last problem. Negative 5x minus 3y equals 38. And negative 6x plus 5y equals negative 6. If you notice, there are no variables that are going to clearly cancel out. And there's not one equation that we have to multiply. There's two equations. So you have your choice. You can either deal with x's or y's. I'm going to deal with x's since it's first. Might as well. What is the least common multiple between 5 and 6? Well, the least common multiple between 5 and 6 is 30. So I want one of them to come out to be positive 30. I want the other to come out to be negative 30. So I'm going to make this one come out to be positive 30. I do that by multiplying it by negative 6. Negative 6 times negative 5 is 30x. Negative 6 times negative 3y is positive 18y. And negative 6 times 38 is 228 negative. Now I need to multiply this. If this comes out to be positive 30, I need a negative 30. What do I multiply negative 6 by in order to get negative 30? Well, the answer to that is 5. 5 times negative 6 is negative 30x. Good sign that they're opposites. 5 times 5 is 25y. And 5 times negative 6 is negative 30. These cancel out when I add them up. 18y and 25y is 43y. And 228 negative and 30 negative is negative 258. I'm at a one-step equation, which I should always arrive at. Divide by 43. And they don't look like they're going to come out to be a nice number, but they actually do. 258 negative divided by 43 is negative 6. So my y is negative 6. Well, if I found y, I need to find x. So I'm just going to pick an equation. I'll go with the first one, negative 5x minus 3y equals 38. It doesn't matter which equation you pick. And negative 5x minus 3, but instead of y, I know y is negative 6. That equals 38. Negative 5x, negative 3 times negative 6 is a positive 18, equals 38. Subtract 18, I'm at a two-step equation. You should always arrive at a two-step equation. Negative 5x equals 38 plus negative 18 is 20. Divide both sides by negative 5. 20 divided by negative 5 gives me x, negative 4. My point is always x comma y. So the coordinate is negative 4, negative 6. There is your final answer to that problem. Again, these are a little bit challenging. If you have any questions on today's assignment, please feel free to Schoology message me, email me, call the Google helpline, or ask your questions during our next live conference. Till next time, bye.